We need to find the complete integral of p equal to z plus qy whole square. First, we need to write this given equation as, we take f to be equal to, I'm taking this p to the other side and equating this to equal to f. So this is z plus qy whole square minus p. You can also take this right hand side to the left hand side, right? So in this example, I have taken this p to the other side, and then we need to use this Charpit auxiliary equations. For that, we need to get the value of fx, fy, fz, fp and fq. Fx means derivating f with respect to x. There is no x, so this is 0. Fy, derivating this y with respect to y. So it is twice of z plus qy multiplied with q. Then fz is derivating f with respect to z. So it is twice of z plus qy. Fp is -1 and fq is twice of z plus qy multiplied with y. Let me write this as 2q and here 2y. And now putting all these values in this auxiliary equations. So dx divided by fp, that is -1, equals to dy divided by fq, that is 2y into z plus qy, equals to dz divided by p multiplied with fp, that is minus p, plus q multiplied with fq. So it is 2yq into z plus qy, equals to dp divided by negative of fx, that is 0, p multiplied with fz. So this is 2p into z plus qy. And then I'm writing dq, I'm writing here dq divided by minus of fy, that is this, plus q multiplied with fz. If q is multiplied with fz, we get twice qz plus qy. So when adding these two, we get 4qz plus qy. Right? Okay. Now we need to choose those ratios from which we can get easily the value of p or q. Because I'm having twice z plus qy common in the second and third ratio. Twice z plus qy is common. They can easily be cancelled out and we can get the value of p easily from these two ratios. So cancelling this, and also 2 is cancelled from the denominators. So we have dy divided by y equals to dp divided by minus p. Integrating both the sides, we get log of y equals to negative of log of p plus the constant log of a. This is constant. So from here we get log y plus log of p equals to log of a. So using the properties of log, it is p into y equal to a. From here we get the value of p to be a divided by y. And now remaining to find the value of q. Either you can get the value of q by equating the ratios, or directly you can put the value of p over here and get the value of q from the given equation. It's up to you. So here I am going to put the value of p in this given equation to get the value of q. So from the given equation, p equal to z plus qy whole square, and we have get the value of p to be a divided by y. So this is z plus qy whole square. Taking square root on both the sides, square root of a by y equal to z plus qy. So from here I get q to be equal to square root of a by y minus z divided by y, which can be written as square root a divided by y the power 3 by 2 minus z divided by y. So this is the value of q I have got. And now we need to use the equation. We have to use now to get the value of z, the complete integral dz equal to p dx plus q dy. So what is p? It is a divided by y dx. What is q? It is square root a divided by y the power 3 by 2 minus z divided by y. And this is dz. Taking y common from the denominators, multiplying this with dz, it is a dx plus square root a divided by square root y minus z dy. Or we can write this as y dz equal to a dx plus square root a y power minus 1 by 2 dy minus z dy. Taking this to the other side, so this is y dz plus z dy equals to a dx plus square root a y power minus 1 by 2 dy. We can write this as the derivative of zy. Yes, so this is equal to a dx plus square root a y power minus 1 by 2 dy. Now we can easily integrate all of this. From here we get zy equals to integration, this a is constant, so integrating 1 with respect to x we get x into a, plus integrating y the power minus 1 by 2, that is y the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 into the square root a plus the constant b. So this is zy equal to ax plus y the power 1 by 2 divided by 1 by 2. So I am writing this as twice and writing this as square root of y, or square root multiply with square root of a, so we can write square root of ay plus b, where b is a constant. So this is the complete integral of the given equation. This is the complete integral of, we can have the value of z from here, the given equation. Alright, thank you.